Is that what we're recording?
Mm-hmm. It's recording right
now.
now.
It's recording. So,
You know all that. I do have some handouts here. You want mine? Well, when Ed called about a week and a half ago and said we need a speaker, Dave and I got together and I found my 07 code book, which I just got, and we did go through it. There were some significant changes. I didn't think there was a lot of them. A lot of stuff had to do with just pretty, what I would call, not real drastic changes, things, a lot of just paragraph changes and some wording changes in some of the sections. And so we just basically went through the book and tried to pull out something that would be pertinent to this group. Certainly not everything that changed in there, but we tried to at least limit it to some of the things that we thought would be applicable to this group. What we're going to go over tonight is some of the changes. There's some required alarms that we want to just review with everybody. There's some of the things that we find in the field that always get left off on the time to start up. If there's time, we'll go over some of the field installation issues that we run across. Also, really encourage any questions that you might have as these topics come up and some of the changes. It would be interesting to hear what you guys have to say about them, or if you think you've got an opinion on it. We'd be happy to hear it and discuss it. They did change kind of the scope of the document to include power supplies and power arrangements. Now, maybe Dave can address that a little bit more. In the past, it's always been kind of a gray issue. Is it National Electric Code, or is it NFPA 20? And he runs into those issues, more than I do, being the fire patrol rep. So maybe you should speak to that a little bit, Dave.
Well, the ongoing issue has always been that, and I'm sure it'll continue, is that the electrical inspectors say that they can't enforce 20. It's not part of the National Electric Code. So they developed years back Section 695, which covered fire pump control, or fire pumps. Then became a confusion layer in there about because there's things in 695 about disconnects and things, and the inspectors that weren't aware of what's going on started saying that pertains to what's inside the fire pump controller. And that was not true. It was only pertaining to what may be installed ahead of the controller. So what 20's done is they've brought in a lot of the stuff out of 695 into 20. They haven't taken it out of 695. It's just they brought it in so that the design people hopefully will become more aware of what the electrical requirements side is. Because it's always been a coordination effort when you get into the design firms. It's been, this is mechanical's territory, and for some reason they don't talk a lot to electrical. They tell them, hey, I got this horsepower motor and I got this voltage, and electrical goes on their way. And they don't necessarily coordinate it properly. And so this is an attempt at NFPA to try to get some of that coordination work done, I think.
Well, I think that'll be should be a positive.
I think it's going to be a real positive thing. I mean, a couple of years back, we ran into one real pointed deal about power supplies. Up in northern Minnesota, way up by the Canadian border, this company built a small manufacturing plant, pharmaceutical company, and they put fire protection in it. And when it was all ready to start up, they were like, well, how are we going to run it? And they said, well, we're going to run it off the standby generator set. And I went, well, that doesn't meet code. The code says it needs to be a continuous power supply. And so we had this argument back and forth, and he says, no, we're going to do it our way. And I said, fine. I said, you do what you want, but I said, it's not the code. And And the local inspector, if they're in a small town, didn't say anything. Well, today, now in the new 20, it says that that's not acceptable. You know, it's finally in there that says standby power supply is not an acceptable power source for fire department. It is if it's an alternate to a continuous, but not as a sole source.
They did have a number of definitions that were either added or changed in there. And one of them is this brake tank, which is like an intermediate tank between a city water supply and the fire pump. And I'm not that familiar with these things, and Dave and I kind of debated, unless we bring this up, we don't even know what we're talking about on this thing. I've never seen one installed, and you know, Ed said he had a little bit of because we asked him about it before the meeting. And I don't know, has anybody else had any experience with installing a brake tank before a fire pump? It's,
I think this is a new concept.
it could be, and
Ed may be right. This may prove to be very interesting in a lot of situations.
I just, basically, can I make a comment?
Absolutely.
The comment basically is that I attended the seminar at the Dallas conference of the AFSA, and the gentleman from the NFPA on that committee brought up the point of the brake tank. Now, this particular code, and I'm not going to steal any thunder from you, so I'm not going to go into any detail, but this code basically allows you to flow city water into the tank on one side while taking suction with your pump from the other side, so you don't get into your churn issue. When you're just churning, you don't go over 175 psi, and that's what the brake tank is all about. It's quite elaborately described in this new code book. It's quite interesting. I don't know of anybody that I know of that has installed it, but when you look at the concept and the drawings, it certainly makes some sense, particularly in light of some of the problems that we've been having lately with no relief valve on an electrical pump.
This was another definition that wasn't in the code book before, that I don't think we saw in there. Which is describing what a fire pump alarm is. It's a supervisory signal requiring immediate action. And I think the point here, at least how we interpret it, was, you know, it's not a fire alarm where, you know, you've got it's not required to have trucks responding to a fire pump alarm. I know some cities do require that.
Well, it seems like over the last year, we've seen many more alarm companies programming their panels to be strobe and horn responses to a pump running alarm. And I just did a startup not too long ago up in Staples at the new hospital there, and that's how it had been programmed. And I went, now wait a minute, let's think about this. You really want to evacuate all the patients out of this building if the pump starts because the jockey pump didn't run? I said, you know, I just don't think this makes a lot of sense. And they sat there and they agreed, so they were going to reprogram that one. But I said, well, and I tried to find out how it got that way, and the alarm company said, well, that's what they were doing that to all their systems now. And so it's something we're going to have to watch for as we go along. I know there are a couple of jurisdictions, Rochester's one of them, where they want to roll a truck if the pump runs. And they just, their thought was, Ross Parker's thought was, is that if that happens, it's because he wants to roll a truck and not bank on the flow switch working. And I did talk to one of the fitters, inspectors here this summer, and he said he was in a building, didn't have a fire pump, but he was in a building, had 3 zones, 3 separate flow switches, and none of the flow switches activated. So, I mean, there may be reason to do that, but I question it. I think we want to do it
There was a flow and no flow switches work.
When they tested them, none of the flow switches worked.
That's a maintenance issue though, that's not a design.
That is a maintenance issue, I agree with you.
And it's always been my opinion to, you know, if I'm asked, is that, you know, the fire pump running should not be taken over to fire alarm.
But the way the people like Ross have said, you know, it's like belt and suspenders. You know, it's life safety equipment, do you want the belt or do you want the belt and the suspender? And I don't think there's a good answer for that. I think it's just a personal preference.
I think it's important that 20 finally came out and gave direction, as you were talking about, as to how the panel, the alarm guys program the signals, because there hasn't been any definition at all.
Right.
And years ago, they were programmed as troubles, which they should have been. And then they came up with supervisory signals.
Right.
But you still had alarm signals, and there was a lot of unclear direction on what, how to do it. So that's good.
They actually define what a high-rise building is in NFPA 20. I mean, there's nothing new here, but I don't think, but this definition had not been in NFPA 20 before. And here's what Dave was talking about a little bit earlier, is they define the power.
Yep.
Power supply, on-site production facility. So you are going to have your own power generation. It has to be constantly running, as opposed to a standby system that may not be constantly running. And here they got a definition for all of us. And here, qualified person. Not quite sure why they needed to put that in there, but that was they added that definition to the NFPA 20.
I think it has to do with the thing that they threw in the annex about parts that get replaced and stuff. I think we've all had issues with standard electrical contractors or repair people getting in there to repair stuff and making a mess of stuff. So I think that's where that qualified person comes from.
They also define what a circulation relief valve is. And that's, we call it a casing relief valve or circulation relief valve. It's a little 3/4 inch valve typically that's on a fire pump that discharges water, enough water to keep the pump from overheating when there's no flow in the system.
It's also called, later on in part of 20, it's also called an automatic relief valve. And I sent a note off to NFPA. I said, what's that? And they said, yeah, you're right, it's used interchangeably, but
And these are just some general requirements I think that they tried to clarify in there. And I think it was actually in there, just not stated as plainly as this, that a pump shall not be equipped with more than one driver. I never knew of anyone that tried to do that.
well, there were some. Back in the 60s and 70s, there was some
Dual
engine diesel
Yeah.
electric. There's one downtown Northstar building.
Where you have a diesel engine on one end of the pump, and an electric motor on the other, and you got a clutch that'll engage or disengage. I don't know about the each driver's got his own dedicated controller. I'm not sure if that was ever an issue where.
I don't know if it's ever been an issue, but I could see where there are some people now, especially with the VFD controllers, that would make a controlling, multiple pumps with one larger VFD controller. It's done all the time with VFDs in regular industry, so I could see some electrical contractor trying to do that.
Now, you label this as new paragraph, but I'm not sure it was a completely new here.
I think that one was.
Well, basically, they're talking about what Ed was talking about before, the brake tank, is that you cannot use a pressure relief valve as a means to deal with the requirements of the lower paragraph there.
Might be a new paragraph just because they moved it in the book, but.
And the other thing that they talked about there is, I think, is they added, might be, is that the pressure regulating device. I think that part of it is new. And so that was kind of the little avenue we had, I think, before, was that if you couldn't put a relief valve in there, but you could maybe put a regulating valve in to keep the pressure lower in the system. And they don't allow you to do that in the fire pump discharge piping. That's the piping from the discharge flange to the control valve. That's the way I interpret that. I don't know if anybody else sees that differently or not.
But Mark, you're basically still allowed to put a suction control valve, is it not?
Yes.
Right.
Same thing.
Well,
Wait.
No, not really.
No,
Because there you're dealing with an inadequate water supply.
and the pump suction control valve is going to restrict flow, not necessarily pressure. The normally closed valve, but once it's open and you've got over 20 pounds of pressure or 15 pounds of pressure, it's going to be wide open if there's flow, and it's not going to prevent any pressure from any excess pressure from entering the system. And so I think what they're talking about there is they don't want a pressure regulating valve sitting in there, with 200 pounds on the inlet side and 175 on the outlet side of it. And they do, I think what they're saying is that if you're going to put a pressure regulating valve in, you need to do that on the individual floors. And that your discharge piping and your, on the discharge piping of the pump has got to be rated for the pressure.
There's actually another paragraph, I don't know if I put it in here, that says that it's not the intent to eliminate pressure reducing valves downstream of the pump discharge shutoff valve. So I don't know if you split hairs with them, if that means you can take the valve and move it to the other side of the thing. I'm sure that's not what they want, but I'm sure we'll see that.
And one of the questions I've had in the past is system components. I mean, how far does that carry out? Is the system components just the components that they're talking about in your discharge valve assembly for the pump? Or does that mean that you're all the way up to the sprinkler heads in the system? So if that was the case, you could never have anything over 175 for most heads.
Well, I think that paragraph there specifically is aimed at those that use the variable speed pressure regulating controls, because there the system has to be designed to withstand whatever the pressure grading is going to, or discharge is going to be with the pump locked and bypass, which means it's running rated speed, maximum output, and you get what you get. So if you're over the 175 at that point, you're going to be 300 pound all the way to where that pressure drops off on the elevation of the building. That's just the way it's going to be.
But they do allow you to put a relief valve in an installation where they have a variable speed control.
They require it, but it's not allowed to open at constant speed operation. It's only allowed to open should the VFD somehow get hung up so it goes over the rated speed.
So if you currently have those inline pressure reducers, you got to clean those.
That is not retroactive.
Yeah.
To my knowledge, it is not retroactive.
And you got one, Gary?
Yeah, we're going to cost a lot.
Yeah. Well, until they defined it in this manner here, I thought it was a reasonable solution to the problem.
It was the only on-site cost-effective way to do it. I mean, otherwise you're talking about throwing an electric controller away to buy a variable speed pressure reducing controller that's 3 to 5 times the cost of the first
And
controller.
plus, they've only been around for a few years.
Right.
So that's where the brake tank comes in, right there. Now this is new. High-rise indoor fire pumps on a high-rise shall be physically separated by 2-hour fire rating construction. That's a new paragraph. In the non-high-rise building, there by the table 5 point whatever there we have in here. That's not a change.
No, that's the same.
Yeah.
There's a change in it, but the only thing that they changed is they flopped in the whole code book. Everything you'll see will be English units first, metric units second. They've gone back to that distribution. So there's a lot of code changes in the code book, but the only difference in the paragraph is that unit change.
So they're indicating all those as changes, but that's all that changed, which makes it a little confusing.
I think the only additional comment I have to that fire pump room was that the emphasis was really put on the fact that it's now only to be allowed to be a fire pump. Do you have one in there, or is that the...
I think I just went ahead to the chart there. This is in the annex.
Right. Both these paragraphs.
Yeah. About the ease of accessibility, and also that you got a paragraph in there about equipment that increases the fire hazards such as boilers and is not related to the fire protection system should not be in a fire pump world.
And it talks about penetration. Yeah, go ahead.
Two warnings about the annex, okay? If you notice on previous slides, the verbiage in the codes are shall not or shall be. These are should, okay?
I understand.
Yeah, because legally, shall is a directive or a mandate, and should is a suggestion or recommendation.
I understand, but I've been preaching some of these things for years because it doesn't make a lot of sense to put a natural gas supply in a room
No, it makes sense.
that has sparks.
But you should check with the AHJ, number one, as far as what their interpretation is, if it's to them it's should or shall. And then number two, there are states and communities that don't accept the annexes or appendixes to codes.
Right.
But at saying that, I don't think they'll stop you from keeping it out of the room.
Right, but
Right.
yet if AHJ, if you design the pump in a room that doesn't meet the annex, and then come back at you and say they want it for the annex, you have some good argument as far as saying that it was not a mandate.
Yeah, our point here, I guess, is that if you design it to the annex, there's not going to be anybody that tells you you can't do it that way.
But if you don't, it's not the end of the world either.
Right.
The key point, I guess one of the key ones is we just did a job down in St. Paul. It's in a converted buildings, turned out to be, and it's converted to condos. And you get in the fire pump room and you got an aisleway that's almost 3 feet wide. And it's about 15 feet back to the controller. The controller is mounted backside to you, freestanding in the room. And so you have to go down that aisle, past the boilers, around the fire pump controller to turn it on. Probably not what you want to be doing in a can.
These are the new paragraphs in the code book. Talks about the rooms containing fire pumps shall be free from storage and penetrations not essential to the operation of a pump and related components. And the storage part of that is probably pretty clean. I'm not exactly sure what the penetrations are that they're talking about. So if you can't have a, is that a pipe coming into the pump room? That's our sprinkler pipe. But I think the storage issue is probably a good thing. There's lots of fire pump rooms that are, full of clutter and other items.
They become warehouses.
Yeah, churches and schools are really notorious for that. You can't even see the fire pump with the controllers. They have mop buckets and shelving in there and everything else.
And half the apartment buildings in town, you go to get in the fire pump room, you can't get in there. You got to pull all the recyclables and everything out of there. The old refrigerators.
And I'm not sure what they changed on the emergency lighting. That was always required. Very rarely seen in a fire pump
It
room.
was required, but you almost never see it.
No, and I'm not sure what they revised in there. They just referenced that like.
Well, I think, they put in the reference to NFPA. Mark and I were just happy they got lights there when we
Yeah.
got there.
Right. And this is what Dave was talking about before, about that your system components have to be rated for the maximum discharge pressure, even if the variable speed controller is running at full speed.
I took liberties, I took that off of one of the slides that Ed brought back from the seminar, so that's why I put David Hogg's name on there. Gotta be kosher when you do this stuff.
What they changed here, we talked about this backflow device, basically saying that in the previous paragraph it was very similar to this. However, what they're saying now is that if they do not permit, if the suction supply does not permit 150% rate capacity of the pump, the backflow device has to be installed in a way that it can at least have zero pressure. And I'm not sure what they mean by effective pump performance, if that's rated capacity, if that's the sprinkler capacity.
I think that's design requirement. That's the way I would interpret it. Because right below that, it goes on to say, exceed the system design.
Yeah, that the discharge shall exceed the fire protection system design as well. So, and there's always been a little bit of an unclear, as, in the past that the code stated that if a fire pump did not flow 150% of the rated capacity of the pump, it does not mean that it was kind of a negative way to say it. It said it does not constitute a failed acceptance test. It didn't say it passed, it just said it didn't fail. So, and I think this is part of that, and then a little later on, I don't know if we have that slide or not, but they did change that wording to that it is acceptable. It is now. If you cannot, the city water supply does not allow you to flow 150%, but they also qualify that you have to at least flow the system capacity. This was another thing they added. They took this from the annex and put it actually into the code. Is the sensing lines. Those were always in the annex, and so it was always, kind of difficult to, I don't know if it was difficult to enforce, but it was just, this brings it into the code, it's pretty specific on how they're supposed to be installed, and there's very good reasons why they should be installed this way, and so we're glad to see that it got moved into the code. This is probably one of the biggest things we see out in the field still with problems on field installations, having the sensing lines either not piped from the right spot on the pipe, or the check valves aren't installed right, that sort of thing.
Lately, I guess the thing I've been seeing lately that I'm not sure I like is I've seen the gauges being mounted on a gauge valve, and that's also what they've tried to use for the test drain. So that valve is serving dual purpose. There's no way to isolate it if you have to change a gauge, or if you have to change the valve, because those valves do go bad. I think the idea of having a separate, whether it be a wall valve or a gate valve or whatever, and then the T with the gauge, and then the other wall or gauge, I think works better. But
no, I didn't go back and verify all this word for word, but it appeared when I read through it, there's nothing new here. But it's just basically
it's just the fact that it's up in the code.
Yeah. There's a typical diagram that comes with every fire drill controller. It shows the proper placement of that. And here's the one that's actually on NFPA.
If I have an issue, back up in the front. If I have an issue here with anything, it's this connection point on the sensing line back to the pipe. I find a lot of places, some of the contractors are still wanting to put that out here on the system. And what that means when it's on the system side is when that pressure switch needs to be maintained, you're draining the whole building down to change that pressure switch. And that's why the code's got it between the control valve and the check valve, so that you don't have to do that. That way we can just isolate the pump and maintain that pressure switch for that unit.
And also that you may allow the bypass to be active too. Depending on where that comes off, if it's not in the right spot, you may have to shut your bypass off too while you're servicing the pump. Now we're into that brake tank. Talks about the application there. The backflow prevention device, which does provide a break between the city water supply and fire pump. Talks about how it eliminates pressure fluctuations. And so what Ed was alluding to there is if you have a city water supply that has a normal static, say 50 pounds, but during the night you can get some big fluctuations where you've got a sprinkler system designed basically probably for your lower static water level, and you've got a big surge that can occur in there, and that's going to put you over the rating for the system components. This brake tank allows you to have a constant suction pressure, although it's basically zero, so you have to design your system accordingly, but it does provide for a constant pressure. I don't know if this brake tank is going to be the answer to all these issues here, but that's going to, I think the fact that you're going to have zero pressure available, then there's all sorts of requirements for filling and how you fill it, the dual lines coming in, it's
The one thing that sounded to make some sense is that, let's say that you have a 2-inch well out in the property, you want to keep on filling that tank while the pump is taking suction from it, or some other means other than enough. In other words, you make your tank big enough, but you're allowed to take into account the gallons per minute that are flowing in from an alternate source, which might be less, as long as the duration is still built into the tank.
But the filling requirements are that if you build a 30-minute tank under the brake tank rule, if you build a 30-minute tank, the automatic refill still has to operate at 110% of the pump rate.
there's a lot of rules in there.
So that's why I'm saying, I think, an underground storage tank or an above-ground storage tank, yeah, it makes sense in a well situation because it has the 8-hour refill requirement. But this brake tank thing, I think, when I saw that 110% flow requirement on the refill, that really is going to limit its applications.
If you have a city water supply, I don't think that's going to be a problem.
Right. But I mean, that remote site, it's not.
I don't know if
gonna be a big deal.
I don't know if you need the brake tank on a remote site with a well because your pressure would be pretty constant, I would think. Anyway, there's a lot to be learned on the brake tanks.
I have a question.
Yes.
We were in a location with a home, and we were trying a similar situation with this. Does the code require that you have your backflow brake tank and a fire pump, or can you use the booster pump to do this?
Supposedly, you can use the brake tank as a backflow.
Okay.
But your question was if you can use the booster pump for what? As the...
Instead of a true fire pump, can you use a different pump to boost your pressure and make this work, or does it have to be a true fire pump?
In a residential situation?
I think it's supposed to be a 13-hour lifted pump, isn't it?
Well,
Residential? We're talking about a home, right?
Yeah.
Not an apartment.
Home.
And you can also now use the well pump for a home.
So it does not have to be
The
a
well
fire
pump
pump.
does not have to be listed, just a plain ordinary well pump, as long as it has enough flow for your calculation.
Okay. So this application will work.
Right, I mean, that's something new again in the 13D, for 2007.
Okay. Thank you.
this is something that was eliminated out of the code, and we've been talking about this for the last, I don't know,
Never get anybody to adopt it.
5 years it's been in the code, 6 years maybe, the last two code cycles, and about a pipeline strainer being installed before any fire pump that you had to remove the impeller in order to, or remove the motor in order to inspect the impeller, which meant an inline type pump. You'd have to have a pipeline strainer ahead of it. Well, now they've eliminated that requirement. Nobody ever put one in anyway, so anybody did it.
Well, there's 2 in Minnesota.
And they did talk about the coupling here, and I'm not sure what they changed there. I think they added a Nancy reference, but maybe that was in another paragraph.
This is something else. This one is just flexible. This one was where they changed the flexible. It used to be a provision there for solid.
Okay.
Not in there anymore.
And then, now Aurora just informed me that FM, and maybe Tom, I don't know if you know this, Tom, that they're going to require solid couplings now on all fire pumps. Have you heard that?
I haven't heard anything of that.
Well, I got a phone call or asked about how I felt about it, but it sounded to me like it was FM's going to require solid couplings on all horizontal fire pumps.
It's going to make field alignment a major pain.
Yeah, so I would say, and there was also talk of having it, that all the existing fire pumps would have to be retrofitted, which I can't imagine that's going to happen. But that was the early discussions on that Aurora pump was talking about.
I don't want to speak for Mark, but knowing the difference in what it takes to align a solid coupling versus a flexible coupling, I can see upcharges coming for starter.
Well, why don't you talk on the power supply requirements for David?
Basically, we've pretty much covered a lot of it. It talks about the different types of supplies. It talks a little bit about the power arrangements, everything that was basically in the annex, plus what was at 695. I mean, we're looking for separate connections directly from the utility feed transformer. Ultimately, they would like to see a separate transformer. Where we're going to have issues, and continue to have issues, I think, is for the high-rise buildings that are taken, have indoor substations in the building, and we're taking separate feeds off of that. There's a section in there now that says that the fire pump disconnect shall be isolated from other disconnects. So that means it probably should never come into that room. And that's going to be problems for building people, for the electrical contractors. If this isn't coordinated right on the front end, there's going to be issues when you get there and you go, well, wait a minute, this isn't per code, that's not per code. You know, what do we do? And ultimately, the only control we have, or I have as a controller salesperson, is that I'm supposed to make sure that the controller is installed per 20. And if it's not, my only lever is the warranty or the liability coverage on the controller. Because technically, if it's not installed properly, it's probably outside of its listing. So those are the issues, and we get into that with, now it covers things like connections. So that when a contractor comes into the fire pump controller, you're supposed to use a watertight fitting. I've been able to tell them that in the field, never been able to enforce it. It's in 20, which means that hopefully now it's going to find its way into 695 in the National Electric Code next rewrite. But we're kind of mid-cycle there, so basically what I've been telling guys lately is, you know, if it's not a watertight fitting on the top of that controller, I'm not going to warranty it. Because eventually there will be water in it. I mean, we got sprinkler heads in these rooms. You know, if they go off, water's going in that controller and your fire protection's going out. I mean, it's that simple. And same for alarm conduits. Alarm conduits are not mandated to be anything but standard pipe and wire. Well, I'm saying that conduit from my controller entrance out to the first box needs to be watertight, and it needs to be sealed at that outlet, at that first junction box, so that water can't get into that junction box and run down the pipe in that controller. And these are they're little things, but the only way that I have to make sure that they happen is to hold that warranty as the issue. So we'll start seeing that. The code now says, you've all probably seen the MI cable, which is the one that, the electrical cable that looks like soft copper water pipe. That mineral installation cable, a lot of it was installed, especially for the bigger pumps. It's one unit per phase. So you had 3 of them coming in the top of the contact and the top of the controller. Well, they were never supposed to land those on the controller. They're always intended to be landed at a junction box and then converted to standard wire and brought down through a watertight connection. Again, I have no power to mandate that. Now it's in my code. I can say, hey, you know, but that was a manufacturer of the wires installation instructions that weren't being followed. So these are the kinds of issues that you'll find out there that the code has tried to help clean up for us. This is another biggie. This one here is, if you're dealing a job that has an automatic transfer switch, you You need to talk to your electrical contractor or the general and find out who's supplying the generator set. Because generator sets typically are not sized for standby duty with a 15% voltage drop requirement. They're going 30, 35, whatever they can buy with. Now, if it's a big facility, so that you got, you know, they're going to take the whole facility on, you probably don't have to worry about it. But if they're marginally sized in that, and they're going to take the fire pump on, and they're going to shed some other loads in the building in order to carry it, might be an issue. We may get there and find out that we can't support the fire pump owner.
What's the symptom of that happening?
What will happen is the contactor will fail to pull in. It'll sound like a gun going off multiple times. The contactor pulls in, the arc flash of it hitting the contact drives it back open, and then it goes back closed, and it does that a few times. And you'll hear it. If you ever hear it, you'll know what you heard, because there's no mistake in it. We just did a school up in northern Minnesota, had that issue. The voltage drop was so severe that it wouldn't start it. There's nothing we could do. We just, call the generator people and say, hey, I don't know whose issue it is, but you got to address it.
So what is 9.4 just telling you that the voltage drop has to be 50% or less?
Yeah. Anybody two is where I said, like we said, generator sets do not apply. Alternate power sources, typically they're second utilities, emergency generator sets, or some cases there are some facilities that still have a steam turbine generator that's being run off of waste heat from their boilers. So that's also an acceptable source. Junction boxes, we've had issues in the past where you get some people that decide they need to run a loop or someplace or something, they're going to tap power off of the fire pump controller. They're going to tap power out of it to go to the jockey pump controller. It's not a junction box. The only wires that are allowed coming in there power-wise, three-phase wires coming in, and the wires going out to the motor. They can't be drawn voltage out of that box to go anyplace else, unless it's an approved fire pump accessory circuit, i.e. a remote alarm panel, something like that. Listed circuit protective system, and it's something you're probably not familiar with, but that's the MI cable was an electrical protective system. There's a couple others out now that go into standard conduit. So you just should be aware, it needs any retrofit that goes on. Any conduits coming through a building, they need to be run in a 2-hour wire or a 2-hour protective system, or they need to encase it in 2 inches of concrete.
Dave, I don't see any CI cable reference in here. Was that on purpose or?
I didn't really talk too much about alarm cable. I don't know where that code stands currently, Tom. Is that a requirement on activation devices?
For survivability is becoming.
Okay, so.
To the next slide.
Yeah, and so you'll see, you probably hear that term. It's called CI cable. It stands for circuit integrity cable on fire alarms. And what it's designed to, if you've ever heard of plenum cable is designed so that in a fire, the insulation drips off of it in less than 30 seconds. It's Teflon, it just melts away, and the circuit's free to short out. They just don't want the smoke. Well, in a circuit integrity cable, it's the opposite. It's a cable that is a ceramifiable silicone compound that when it gets to 900 degrees, it starts a conversion process to ceramic. And it will withstand 1500 degrees for more than 2 hours. So it's designed not to let that circuit fail. And I know that the fire alarm code's been working on this for a while on remote smokes and stuff as far as the signals down, but I've not had anybody bring it up as far as fire alarm inputs from the fire pump control. But I could see where that could be desirable on all circuits. Raceway terminations, that's what we were talking about. MI, MC cable, any of those 2R rated systems should be terminated outside of the controller and then converted back to standard wire. I say recommend the following be written on the inside of the controller. This is actually in the new code as a mandate on variable speed pressure limited controllers. It does not mention it outside of that type of controller. Mark and I have been trying to do this for some time on the jobs that we go to do startup on, because if anybody has to come do maintenance on it, they need to know what the set pressures were at startup. So that's where this log is kept. So we just try to write it on the inside of the door in an indelible marker. One of my little, I don't know, I won't call it a pet peeve, but it's an issue. Viking got hung on a couple of these things a few years back on a retrofit job where there was an existing engine application, they replaced the engine, and the fire marshal came back and said, there's no ventilation there. There's no makeup, there's no combustion there. And all that stuff was not there the first time. You know, all they did is take the old pump out, drop the new pump in, and so they get stuck. And it's, you know, as contractors, you all need to be aware that the AHJ is probably going to look around and say, hey, this needs to be brought up. It happened again this last year on a job, one of the United Property jobs out in Inver Grove. It's a building that had an engine and an electric fire pump in it, and they added an engine. And when they added the engine, they went, I got there and I'm looking around the room, I'm like, there's no ventilation in this room. Fire marshal right away. He's like, what else is missing? Yeah. So, you know, in that particular case, they had to put engine combustion air inlets, ventilation air, the powered exhaust, the low air temp that was on the new controller for the new diesel. The drain, they decided to drain it back into the reservoir that everything was sitting on top of. The lighting was already there. I'm not sure if the emergency lighting was ever put in, but and the heat was there before. But been in some of these buildings where there's been no provision for heat. There is no provision for engine, either ventilation or combustion air makeup. The ventilation's important because we get fumes coming off of these engines, just like your car engine. The breathers coming out of the crankcases and stuff, they put oil fumes in there. The heat that that engine dissipates is about a third of the horsepower fuel that it burns is coming back in radiated heat. And so to think that that room's not going to get over the 104 degrees that that engine's designed to run at rated horsepower curve is ridiculous. That room will get so hot so fast if it's closed up and there's no ventilation in it that you will lose horsepower and you will lose pump performance.
Dave, where's that room low air temp alarm go? Typically, what is that connected to?
Well, typically what we try to do is we try to provide it as part of the fire pump controller, and then it comes out as one of the common alarm points.
So that would be one of those supervisory points?
One of those points that we're going to come down to here as far as the required alarm hookups. It would be nice if people would break it out as a second alarm, but that, unless they order it that way on the controller, it's not going to be capable of that. We can always field modify it, but that's not a standard.
So from the alarm standpoint, we need to coordinate with the controller to see if it is set up to acceptable wear and alarm. Number
Right.
one. And then-
Because if we don't have it on the controller, then as alarm contractor, you should provide the thermostat for that. And the thermostat setting requirement in 20 is that should be set at, I think, 45 degrees. This is new because now they're talking about a double-walled pipe for exposed fuel lines on diesel engines. Well, we have, out of all the diesels I've seen, I bet since we did the mail garage, I don't think I've seen a guard around a diesel fuel pump or fuel pipe, and it's always been in the spec. But now they're talking about you put a guard around them, or you can use the double-walled, the approved double-walled pipe. Number one, fuel. Number one is what the truckers switch to in the wintertime. Number two is their summertime fuel. It has a higher BTU content. So if you're going to use number one, you need to make sure your engine's rated on number one for the horsepower unit. You can't just automatically say, well, the fuel tank's in a cold area, so we have to go to number one fuel. So it flows, the engine runs. It's like, no, because you're affecting the other side. You're affecting the horsepower performance of the engine. So make sure if you're going to switch to number one, that you talk to the engine manufacturer to make sure you get your horsepower you need out of it. And not all manufacturers will approve number one fuel for their fuel injectors in their engine. For this, for fire pump, no. I honestly don't, because I don't see the risk of the contaminated fuel, because some of that stuff I think is going to be able to gel, especially where they're mixing back the French fry grease and stuff. Yeah, and if that stuff starts to gel in the fuel line, it's over before it starts. Exhaust emission after treatment devices. What they're talking about here is air quality standards. There's going to be jobs that are probably going to require catalytic converters and that type of thing. And this addresses, there's code now that addresses the installation of those. If it's required, it seems to me that what they really want to make sure is that there's an automatic bypass some way that the back pressure there doesn't choke the engine off from delivering its horsepower. It's good paperwork. I can't tell you where you can go buy one of those devices today. Diesel fuel storage. This is change here again. We're back to 66%. Tanks need to be kept 2/3 full. Was 2/3 full. They dropped it to 50%. We're going back to 2/3. And I don't know the reason for that, but that's the change. That's why the paragraph's in there.
Dave, go back one. Was that requirement for the fuel level
Fuel level indicator?
Has
I
that
don't-
always been in there?
I don't remember.
I don't think
it has. I think that you're right, Mark. I think that's also new.
That'd be something too for the alarm guy. I don't know. They just, normally we just wire that right back to the controller.
We normally wire it back to the controller, and then the controller sends it out. I've always recommended that it be sent as a separate point. In fire tow, we have the contact outputs to make it a separate point. I've always recommended it be used that way because they don't need to send somebody to the room if they know they've got to call a fuel delivery truck. Counterproductive in my mind. Now, all your customers, or most all your customers, will probably get upset that they have to pay for more fuel than they're getting delivered, because the problem is with most of these situations is the fuel delivery people have a minimum charge, and very seldom at that third of a tank will you ever see that? It's not going to happen. I mean, they're going to be paying for 300 gallons of fuel or 150 gallons of fuel and only taking 50. It's just the reality of it. This is a storage issue, and I bring it up because we keep seeing diesel fuel tanks in buildings that the tank is larger than the area in which it's supposed to be. So what we have is, if you look here, on the combustible liquids, class 2 is diesel fuel, 120 gallons right there in a closed space, non-sprinkler. Now if you put it in a sprinklered space, you can go up to 240 gallons. I don't know where it is. They do pull the wrong turn.
Oh, it's right there, that there. Increased by 100%.
Oh, yeah, okay. 100%, increased by 100% in a sprinkler room. So typical, I think Mark and I talked about it, a typical fuel tank in a small diesel engine is about 180 gallons. So you're right away, you're over that 120 gallon requirement. But then if you get into a higher horsepower one, you start looking at a 300 or 350 gallon tank. Now, technically by the code, by the building code here, that should be in a walled off separated room. So it's a point of information. Not all fire marshals are going to catch it, some will. Brooklyn Park caught it on a warehouse job a number of years back, and they were okay. They didn't make them wall it off. They made them mark the tank fuel gauge so that the delivery driver would know not to fill it more than X full. Yep.
Would that be a separate permit by chance, or is that for that storage tank room, or?
I have no idea. I just...
When I was in Florida, they made you pull a separate tank permit.
Well,
That separate.
In some areas, I know if this were a standby generator, you'd be doing all kinds of permits, because there's DNR permits and there's all kinds of things when you start doing this. And I have not heard of anybody having to pull those kind of permits on a fire protection job yet. But yeah, I think there could be all kinds of hoops coming that we don't know about when it comes to diesel fuel. This is kind of, I don't know, I honestly just don't know why this paragraph is here, because I've never seen that on a diesel fire pump control. I've seen people put these after the fact. I've seen them go in and put this type of protective equipment in fire pump controllers and prevent them from working, because I've disconnected so. City of Minneapolis had a housing, one of the Minneapolis housing units had one installed by some electrical contractor that was trying to keep the city from having a pump controller burn up. Because what you have to remember is all the old controllers were de-energized to run. So if you lost one phase in the controller, there's a good chance you're going to lose a contact. So the system's single phased on. Well, all the new controllers now are single phase sensitive because code changed. They allowed them to be energized to run rather than de-energized to run. They've added a component replacement testing table to 20. It's pretty interesting. It goes into the fact that, you know, when certain things get tested or changed or repaired, you may have to run a complete acceptance test to put the controller back into service. Sometimes you just have to run a churn test. Sometimes you don't have to do anything other than prove it starts. But there's a lot of items in there where churn tests complete acceptance test is required. And they apply both to the controller and some to the pump, the motor. And those are all things we knew in good conscience we should be doing, and I always recommended it, but now they put the table in 20.
Well, this one here, they just made a change because they inadvertently took, I think it was the upper left.
Yeah, they dropped this drawing out.
Yeah. They got it eliminated from the 03 code and they put it back in.
This is a form I think that would be interesting, from my standpoint anyway. I would think that it's probably benefit by having contractors fill some of this out for you guys, the general, keep a record of this. Based on the number of times we've gone to do startup over the last couple of years and the amount of rocks that we've pumped, it would be nice to have somebody have a filled out flow certificate so that when something happens to that pump, we know who to go after. Because, I mean, I've seen rocks bigger than my fist come into some of the pumps. And this is not a good thing. You know, we've got people out there still flushing these systems, and they're only flushing it with a 2.5-inch hose. I mean, that's not a flush according to the code, but that's what they're doing. And that's why we're pumping all the rocks we're pumping when we get there. So I would encourage people to find, before they call for startup, to make sure somebody's actually done that test and has put their name on it. It may not stop us from, but at least then we all have the assurance that, hey, it was done. I know this last one, Tom knows what I'm talking about. One of the last ones we got rocks in the pump. I don't think it was because they didn't flow test it or flush it right. I think it was because between the time that they flushed theirs and the time we were there to do tests, the neighboring property had a connection made. And I think that's where our rocks came from. But that's why even as well as they can flush them, if they flush them to the code book, there's a good chance we'll still pump rocks because we're drawing water through that city water main at a velocity that they'll never get on an open hydrant. And some of you, a lot of you have probably seen this. This is in the code book, 20 book down back in the annex, but it's actually an NFPA form. So, and it's about pump tests. I just put it in there so that if anybody, thinks they're looking for something that they want to use, that form is there. Anybody want to stick around? Pump suction control valves is something, we have just a city of Minneapolis requirement for, or the state of Ohio for those companies that do business outside of Minnesota. Basically, it's a valve, has a sensing line, it runs back to the suction side of the pump, and it'll throttle open and close based on having enough suction pressure and the flow demand. It's a normally closed valve that opens with flow requirement. Here's the piping schematic for the sensing line. Here's the pump. Here's your city water supply. Main shut-off. Sensing line just looks just like a controller sensing line. 1/2-inch pipe, same orifices, everything, because that'll allow us to test it. It's not a code-required sensing line arrangement, but it is the only way that I know of that you'll be able to test that valve down the road to make sure it works without starving the pump. Because in most cases, the pump will have to be running and water will have to be flowing in order to test that valve. So then you come back here, it goes to the pilot valve line, and then you have your same valve, gauge, valve setup. And you notice that these checks are in backwards. Fire alarms. You catch a lot of grief when we get to jobs and we start telling the alarm contractors that they're short points. And I understand it's not their problem. It's because the designers of the alarm system or whoever laid it out didn't put them on their drawing. And it's the first thing I tell them. I know it's probably not on your drawing, but these are the standard 3 that on electric pumps they all know they have to have. These 2 here, when we get with the transfer switch, are the ones that are always missed. And then, like I say, now with the newer computer controllers, I recommend that a common alarm be wired on all of them, because it's that common alarm that's going to pick up things that are wrong, like the memory's full, the memory battery's dying. Those alarms only come up locally, and the only way you're going to see them is if you use a common alarm output. Or you can use the new Fire Troll one, which is, you can tie to the web and do it that way, but whatever. Basic requirements here on diesels. Again, 3-point. Some people would say it's 4 because they want to break these 2 up. But the controller manufacturers are only required to put 3 points in the panel. So you'll find that most of them only have 3 points. The engine and the controller trouble is a common one. The switch not an automatic, meaning that the selector switch, which is manual, off, auto, in most cases. Some of the manufacturers still have a test position. Anytime that switch is anywhere but automatic, the fire alarm panel is supposed to know about it. And then the pump running. The additional alarms that we recommend: low fuel level, low pump roof count. And again, the common alarm is already this engine controller trouble. So that's why I don't have the common alarm listed here that I had on electric. This is an issue that we see still in some situations, not in the city, but when we get into rural areas. We still find that they've wired them with solid wire, number 12 pipes wire, typically what they get wired with. That's like, no, it won't take the vibration, it'll fall out of the connector. So that's why the code book says standard, or stranded. I just put in here for reference, fire trellis requirements. Typically we require 3 wires that need to be either number 10 or number 8, depending on how long the distance run is. And the rest of the wires can be number 14. Test headers. I don't know, it seems to me a couple times in the last year I've run into a pump somewhere that had test headers still in the pump room. Code book says it's not supposed to be there. So, it's dangerous, because if you start putting that and running the hoses out through the door, if something happens in the pump room, you got to be running across those hoses. It's just not safe. Here's the old problem. This is an old photo, and I admit it. But this is where they've tapped the jockey pump wires off the incoming, with the incoming power from the utility. And I can't believe they're saving that much money, but that's the way they seem to do it. And we still find probably a couple of years that contractors have done that one. Here's your storage issue. This happens to be just a large warehouse that doesn't have an independent room. But, you know, we got empty plastic bottles stacked on a pallet, less than 3 feet from the controller. I mean, if that ever gets lit, that fire pump's out of business before it starts because that heat's going to take that controller offline. And heat is the enemy. Controls are designed to operate at 104 degrees. Okay, you go above 140 degrees, and the circuit breakers will trip early. Another one where the storage is an issue. In a common room, there's boilers and there's chillers and air handlers and vacuum pumps and all kinds of stuff in that room. Then this is the maintenance guy's desk right here. This one, I don't know, technically it might be okay. I'm told that's fire-treated plywood. I just don't like wood in fire protection equipment. I consider a non-combustible surface to be plasterboard or plaster or concrete block or this is the circulation patient relief valve. The code book, by the way, the code book now states that these backing grips and this discharge shall not be connected. And we still find a few of those a year where the fitters have piped them that way. And honestly, they'll almost always pull out a drawing and say, see, that's the way it shows it. This one point here about the union, these valves are a throwaway item, and during testing and stuff, they will start to leak. So if you put this union up here next to the valve, it's going to be a lot easier for everybody to change it. It's just a housekeeping issue is all it is. This one is our drain issue. It's supposed to be a drain in all fire pump rooms. This is in a pit next to a tank, underground storage tank. The supply line coming from the tank was leaking, so it was water was coming along the pipe at the end of the room. And there's about 4 inches of water down here. This 2x4 that's right here is floating. This is sensing lines, and again, it's a housekeeping issue for down the road. But, you know, it's kind of nice when this drain line gets put up high so that the customer can get a bucket under it when they do their weekly testing. But if you do that for them, I'm going to ask for a low point drain down here at the bottom, because when I got to drain that pressure switch, I don't want to have 4 feet of half-inch pipe water coming up inside the controller when I take the pressure switch. Just a little bit. Did I miss something? Anybody else got any questions, comments? Darts to throw?
Well, you certainly tried to get to the 2 hours. I saw a few people walking out with their tags on and going, oh my God, this is going to cost money tonight. But when you leave, please put all the tags back on the table because we do use them again when you show up for the next meeting. So I just wanted to point that out. But does anybody have any questions? I have the impression that questions were asked sort of during the presentation. Was there anything specifically that you would ask when you said first here tonight? Or is everybody kind of ready to go home?
Oh, I got one more thing. Just one other thing that I was told in a conversation with Dave Stigura is that when they adopted the 2002 International Fire Code, that automatically adopted NFPA 25. There are several things in NFPA 25 that are not being inspected or tested with your annual flow test. Controllers is one of them. I mean, the internals of the controllers. Underground storage or storage tanks, I think, is another. Very few of the customers out there, I guarantee, are aware that their storage tanks are supposed to be internally inspected on a 5-year basis. So, just a heads up.
On the same note, I talked to Dave Speaker too regarding code changes. Right now, the state standard for NFPA 13 is 99, and they're going to officially adopt 2002 this spring. And in return, regarding NFPA 20, I think 2003 will be adopted at that time too.
But that's been in, I mean, that's, what, 25 is 02, right? Or,
Yeah, there states an
Yeah.
addition behind.
right.
Yeah, but they will, again, allow you to utilize the latest code, but you have to use it in its entirety.
That is coming back in again? Because that was out last year, was it not? But Jerry roasted out coming in? He was not allowing that?
Yeah, well, it's going to be revisited again this spring, as far as 2002-13, 2003-20.
Okay.
But it's, again, the caveat that if you use the latest editions, like 2007, 20, and 2007, and NFPA 13, you have to use it in its entirety.
Wonderful. Would you gentlemen please rise? The two of you.
Are we safe?
I unfortunately don't have anything to throw, but the point is, it's a lot of work to put this together. And I really appreciate you guys doing this for us. Thank you very much. And everybody else, have a wonderful evening. Hopefully we'll see you again in the new year and leave your tags to work. Thank you very much for coming.